Good morning. Welcome back to Pre-Algebra. What we're going to be talking about today is decimals and place value. But before we get started, I wonder if you know what it is that the astronaut said when he found bones on the moon. He said, "Well, I guess that old cow didn't make it after all." So we have this beginnings of a little bit of a chart up here. We're talking about the fact that our number system is a decimal system that's based on the number 10. I'm just going to be referring a lot to our text here. This is section 3.1 in our pre-algebra book that's published by Bob Jones University Press. What we have in a decimal system based on 10, on the number 10, we have 9 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And using those 10 digits, we can create any number in the world that we want to create. And in a decimal system, the value of each digit in there is, of course, dependent upon the position of the digit in the number itself. This is an easy number to look at. We have 1,234 and 5,678 10,000s. But what if we had a bunch of fives? Well, we're not confused at all on this. We know that the value of this 5 is a whole lot different than the value of this 5, and that's because of the position that it has in our number, which has to do with its place value. This is 5,555 and 555 thousandths. So this is the foundation of a decimal system. I want you to notice where this decimal point is, right here. This is where we go from whole numbers to fractions of a number that are less than 1. And I want you to go ahead and make sure that you study your book. This is page 79 and page 80, and make sure that you understand place value. Thousands, hundreds, tens, ones, sometimes they call these units. Tenths, which can be written as 1/10. But this place value here is the tenths. This one here, hundredths. And I have never been able to say the names of the fractional parts very well, so you just have to bear with me. This is thousandths, T-H-O-U. And this last one over here is in the 10,000ths place. Let me use a different color for our whole number place values. This is ones, tens, hundreds, thousands. Doesn't take long to run through these markers. This is a new one that's already running light on me. Let's just go ahead and put a 9 in front of there, and we'll carry this one down and have this be 10,000s. A couple of things that I want you to notice about this vocabulary. You do need to be able to write these words. You need to be able to differentiate between the two. The 3 is in the tens position. That means for each value, and the multiplier here is 10. If you have 3 tens, the value of the 3 here is 30. 3 times 10 is 10. Look over here though, the 5 is in the tenths place. Tens and tenths. This is 1/10. Hundredths as opposed to hundreds. This 2 has a value of 200. This has the value of 600ths. To compare, 1/100th of a dollar is a penny. So this is 6 cents over here. This is 200. And I don't know about you, but I'd a whole lot rather have $200 than 6 cents, which is 600ths of a dollar. Then we have thousandths, which is 1,000. We have 10,000ths, which is 1/10,000. When you read a number, something that people say a lot that is incorrect when they're reading a number is they put a whole bunch of ands. In the name that they give to a word. The only time that you say and when you're reading a number is at the decimal place. You can almost say his name is and. This first comma here, his name is 1,000. The comma over here that we don't have, his name is million. So what you do to read this number, you can divide it up into groups of 3 and you repeat how you say it. Let me show you what I mean. 123,456,789. As you know, just by counting your numbers, what you're doing is you're just counting over and over up to 999. You only name that word using hundreds, and then these commas are what determine if you have thousand, million, billion, trillion. I'm hopeful that this is something that's nothing new to you, maybe just a little bit of review. Maybe the decimal portions are new to you. Do you notice anything different here? We have ones, tens, hundreds, thousands. But we didn't start over here with oneths, we start with tenths. 4 and 5 tenths. Let me go ahead and erase these names here. You need to be able to look at a number though and know what place it has so that you know the value of the number. And this shows up when you're using something that they call expanded notation. It helps you come up with the actual value of a number. But before we do that, they're going to have you do a little bit of practicing where you are converting from English into the number and from the number into written English. For example, it says write a word name for the following decimals. 14.8 would probably be how we would name this number, 14.8. But they want you to be sure that you can say that this number would be written 14. What's the name of the decimal? His name's and. 14 and 8. The way you write a decimal number is you read the number after the decimal point, just as you normally would. You take the name of the place that the last digit is in. This is in the tenths place, so this would be 14.8, 14 and 8 tenths. Remember I erased the tenths here? This is what they're asking you to do, 14 and 8 tenths. Only place that you're going to use and is with the decimal point. If we have this one right here, I'm not going to spend the time to write this. I'm pulling this exactly out of your text. But this is a good one to illustrate how you name decimal numbers. 185.007, okay, we might read this 0.007, but this is what its actual name is, 185, and what we're going to do is just read that number to the right of the decimal. You don't read the zeros in the front. This is 7, and then you're going to write the name of the place that it's in. Tenths, hundredths, thousandths. So it's 7 thousandths. $185 and 7 thousandths is how you would name this number. And then let's say that you have this 0.0062. I'm not going to read all those zeros at the beginning, so this is read 62. And what place value is the fourth one over from the decimal point? Tenths, hundredths, thousandths, 10 thousandths. So this would be written and spoken as 62 10 thousandths. It may seem like we're beating a dead horse here, but this is something the naming of numbers tends to get dropped or not paid a whole lot of attention to, and it helps you if you can at least understand what's going on here. Now we want to talk about something that they call expanded notation. I'm going to stop using this purple marker, which is not very bright. What we mean when we're talking about expanded notation is taking a number, 120, let me use the one again that they're doing, 126.83. And we're going to come up with the value of this based on the place value, or the position of each digit that we have in here. So we would have 1 times 100 plus 2 times 10 plus 6 times 1 plus 8 times 1/10 plus 3 times 100. This is what they call expanded notation. And it might look a little bit weird, but it's really pretty straightforward. The 1 is in the hundreds place. How many hundreds do we have? We have 1. This digit 2 here is in the tens place. How many tens are there? There's 2. Well, doesn't this value right there, if we had only a 2, that would be 20. Well, isn't it? That's because we have a 2 in the tens place. 2 times 10 is 20. The 6 is in the units place, so we have 6 times 1. And now we have 8 tenths, and we have 3 100ths. If this is new to you, just do some practice. They're also going to ask you to be able to write an expanded number as a decimal. If I go ahead and erase this decimal already, how would we go backwards with it? Well, let's see. One times 100, 100, plus 2 times 10 is 20, plus 6 times 1 is 6, plus 8 times 1/10 is 8 tenths, plus 3 times 1 is 3 hundredths. And then just go ahead and combine this. We have 126 and 83 hundredths. I don't want you to get real hung up on this. I think this might be something that it's a little bit more difficult for me to try and teach than for you guys to actually sit down and play around with. Don't get bogged down into it, but play around with it for a bit and you'll see that it's not quite too bad. And actually, I'm hoping that most of you are sitting there watching that video and saying, oh, okay, Miss Betsy, what's the really big deal here? This is so easy. So, how do you compare decimal numbers? We're going to use comparison symbols. We're going to say less than, greater than, and equal. We compared numbers. We knew that 2 is less than 3. 3 is greater than 2. 2 is equal to 2. The point heads towards the smaller number. 2 is less than 3. 3 is greater than 2. 2 is equal to 2. And we're going to use the same process to compare decimal numbers, but how do you do it? Very, very straightforward. We're going to compare 8.7039 and 8.705. Which one of these numbers is smaller? Which one is larger? What's the size of this number, the value of this number in relation to the second? Now, this seems very obvious to me. 7039, 7039, 10 thousandths, 705 thousandths. But if we wanted to compare them with the same, so we had the same number of decimal places, you can add zeros at the end. 7,039, 7,050. This number is smaller than our second number. It's less than it. But it could be that I've done decimal numbers for so many years that it just jumps out to me and it's something that I don't think about. So what's another way that we can look at to compare these decimal numbers? When you're comparing to see which is the greatest, you keep going until you look at each digit until you find a digit that is different. 7 is the same, 0 is the same, when we get to the tenths, hundredths, thousandths place, that's where we come up with the difference in the digits. You compare those digits as if they were whole numbers. Because 3 is less than 5, 8.7039 is less than 8 and 705 thousandths. Let's do another one. Let's compare 2.02 and 2.202. Now I want you to notice that our comparisons are having nothing to do with the number of places after the decimal point, because this has to do with place value. Just compare until we get to a difference in the digits in the place. In the units place or in the ones place we have 2. In the tenths place we have 0. In the tenths place we have a 2. So this number is smaller because the digits that we're comparing are the 0 and the 2. What about 17.3462 and 17.342? Ones, 7. In the tenths we have 3. In the hundredths we have 4. Finally, in the thousandths we can compare. We have a 6 and a 2 that we're comparing. Because the 6 is greater than 2, this entire number, 17 and 3,462 10 thousandths, is greater than 17 and 342 thousandths. Just practice with these. That's the end of this section, and I'll see you next time.